Hello again. In the last class we have seen about data structures, its types, linear and nonlinear data structure. In this lecture we will be seeing about what is abstract data types, that is ADT, and then operations of arrays. Okay. After this session you will be able to understand what is ADT and its operations, and then what is array and their operations, and linked lists too. We will go into the topic. An abstract data type is a logical description of how data is viewed and the operations that can be performed on it without specifying how it is implemented. The explanation is very simple, that in the abstract data type it refers to how data is viewed. For example, if I say a number 5 in C program or C programming point of view, or in Python, whatsoever coding you are taking, in their point of view 5 is a integer value. So how data is viewed? This 5 is viewed as integer, and operations that can be performed with the number 5, what all the operation will be performing? We can add it to another number, we can subtract it to another number, we can do any other mathematical operations on that number, right? So ADT is a logical description of how the data can be viewed and how what all the operations can be performed without specifying how it is implemented. In the sense, how I am going to multiply 5 with another number is not necessary. Multiplication is possible or not is the key there. Okay. If you see the right side diagram, if you see application program, okay, interface, then interfacing we have public functions, private functions, arrays, data structures, everything. This is abstract data type. Okay, what are the data we are providing here, and what are the possible approaches that can be performed on the data is the abstract data type, not necessarily how it is being implemented. Okay. Sorry, I'm not quite feeling well. So example of this abstract data type is list, stack, queue, tree, and graph, which are all covered in our syllabus actually. First, a list ADT. List ADT is a ordered collection of elements where elements can be accessed by position, elements can be inserted or deleted at any position, which means a list ADT is a set of elements, to be simple. That set of elements may be from an array or list or whatsoever it is. That elements, it can be accessed by its position, or in other words the address, and these elements can be inserted or deleted at any position. That operations can also be done in the list ADT. Okay, so this operations of list ADT are insert, delete, search, and traverse. Traverse is nothing but displaying the or showing the element. First, list using arrays. Okay, we know what is array, right? A set of elements of same type will be placed together in the set of boxes. Boxes are addresses, we can say. So in the after this array, as I previously said, the student can understand how operations of list can be done using arrays. Okay, an array is a collection of similar data elements, and these data elements have the same data type, which is we know before. The elements of the array are stored in consecutive memory location and are referenced by an index. Okay, this address or position, this can also be termed as index or subscript. Okay, which points to the element. The subscript is an ordinal number which is used to identify the element of the array. So if you see disadvantage of this type is size of the array is fixed. If I say this array size total size is 10, I can fix only 10 elements there, or even if I fix 5 elements, the remaining 5 will left unoccupied. Okay, so the memory wastage is also be happening here, and inserts and deletion requires movements of elements and is time consuming, and wastage of memory, if as I said the first itself I said wastage of memory for allocated memory is not used. So this can be overcome by few operations. First operation is creating an array. Creating the list. Creating the list is very simple, that there is no array present there. So what we are going to do is we are going to create the list. Okay. So for creating, when there is 0, creating one is just giving the code as create, or in other terms we have to create a list, linked list, to create an array. I'm saying, what is that we have to do? First we have to fix how much memory should be there. Okay, and we have to give a name to it. Okay, these two are the only thing needed. The elements presenting inside and all is the second part. First part is what to create. When you want to create something, what you are going to create, what is it, and what is the name of it. Okay, those three are given in the coding itself. Define max size 10. Okay, you are writing the function name to max size 10. Okay, so the max size of the list is 10, and we are initializing the size as 0, so that now there is no elements, but the max size is 10, so that 10 elements can be inserted. Okay, that is the second step. First create is completed. Okay, the variable max size denotes that size of the array, and size represents the number of elements. Okay, and since the list is empty, size is 0 now. So take it kind of a story kind of thing. First creation is completed. Now since the size is 0, we can add in 10 elements. Now you start inserting the elements. Okay, when you want to insert an element to the array, what you should do? First you should check whether there is the possibility to insert an element, which means that array is full or not. Okay, if you confirm that array is already full, the insertion cannot be done. But if array is not full, then you can insert the element based on the space. Okay, that is what mentioned in the statement here. To insert an element at the intermediate position, actually they are saying it, we are saying it in the inserting at any position. But for inserting the first element, or inserting the last element, or inserting any element, first you should check whether the array is having space or not, array is full or not. If the array is not full, we can insert. So here we are discussing about intermediate position directly. So intermediate position requires movement of elements from element after the position to be inserted by one position to its right. So when you want to insert the element, say for example here in the, if you see here if you want to insert an element at 3, then what you should do is, and you have one element left after checking whether the list is full or not. So if you want to insert the element at the address 3, then you have to switch these all elements to the next, so that this will get empty, and that you can insert 3. The element which is going to be present in the address 3 can be done here. This can be done with the help of coding. So on the coding, what they have done, what if you have done is void insert int pos and int val. Pos is position and val is value. Okay, so we are writing a function for inserting. First we have to determine what position you are going to enter, then you have to define which element you are going to enter in that position. Okay, for this first it has to go for a conditional statement where to check whether size is less than max size minus 1. Max size is the total occupancy, and size is the number of elements present already. Okay, why minus 1? In the sense address usually starts with 0. Okay, so if position greater than or equal to size, equal to 0, which means whichever the, if you are giving because the position starts at 0, and the position should be greater than 0 and equal to 0. So if your position is greater than or equal to 0, and if your position is less than or equal to size, because size is the total number of elements. So if position is if position satisfies these two conditions, then you go for the for loop. The for loop, what they are doing is int k equal to size minus 1, k greater than or equal to position k minus minus, which means that say for example take the max size is 10 and size is 5. Okay, you have to insert the element at third position and the value is 5. Okay, So int k is equal to size minus 1. Size is 5 I told. So int k is equal to size minus 1 is 4. Now the k equal to 4, and we are checking whether k is greater than or equal to pose yes, and k minus minus. So what happens now? K becomes 3. So list of k plus 1 equal to list of k. So list of 3 plus 1 is 4 equal to so sorry, here k minus minus happens at the last. So list of k plus 1 is 4 plus 1 5. So list of 5 equal to list of 4, which means that the address present in the 5 sorry, the value present in the location 5 4 will be transferred to 5 here, and list of position equal to value. So when this fourth element in the 4 moves to 5, 4 gets empty. So now the positions and value which you are defined at the beginning will come here. Okay, and size is incremented. So this is being running in the for loop till we get the last size. And if this any of the if condition fails, then it comes out and says that if the second if condition position greater than or 0 and position less than or equal to size is not applied, in the sense not achieved, then it prints as invalid position. If max size is not equal, not lesser than max size minus 1, then it prints the as list is full. Okay, next we discuss about deleting an element. So to delete an element, the position is the process is very simple. First you have to check whether the array is empty or not. If the array is empty, you cannot delete anything. Okay. So if the array is not empty, then you can delete any element. So first you have to decide on which position you have to delete an element. Okay. Then the same thing is followed. Position checks for greater than or equal to 0 and position less than or equal to size. Okay. So so whichever position you want to delete, just move the position into position plus 1. In the sense, if you want to remove say for example in the given example I am saying, so 23, in the sense sixth position element is deleted, so removing 23 element, so position is 6. Okay, so in this coding what happens, list of 6 is equal to list of 6 plus 1 is 7. So list of 6 is equal to list of 7, in the sense 7th position element comes to 6. Okay, and then size is decremented. So for every position you are going to switch. Okay, so 7th position comes to 6, and then size is decremented, then 8 comes to 7 and size decremented, and 9 comes to 8. Okay, this is being repeated. If this condition, first condition, if condition is not satisfied, it means that the elements cannot be removed. Okay. Search operation is, if you want to find any element in Word or in Excel, if you want to find an element, you are just clicking Control F, and we are checking for any value, number, name, any keyword whatsoever it is. Okay, this is happening because at the back end this coding is being implemented. Okay, how this is implemented is, just forget the position, just search using value. Okay, run the loop from 0, check for value. If the value is found, it will return the element. If it is not found, element not found. Okay, it's very simple, and this find application is found to be very simple, but this has major application in anywhere. If you take your phone contacts list, call history, image, WhatsApp message, Instagram feed, any Google search, okay, Excel, Word, PowerPoint, whatsoever it is, you take anything, this find application has variety of applications, and it covers almost all the applications and softwares, right? Whereas this function is very simple. I mean the applying it is in the coding is very simple.